Hello, our team proudly presents to you a unique and amazing sundial project. Yes, we are talking about the clock where the sun is in charge of giving us the time. And not all sundials look the same, and we cannot calculate them the same way. It depends on the place on Earth where the sundial is located, and of course on the designer's preferences. It means that to design and calculate a sundial, we need to know our exact location, or what is the same. We need to know our local latitude and longitude.
You may be asking what latitude is. Latitude is represented in a map as an imaginary parallel or circle. The biggest circle is the equator with latitude 0. Latitude is how far we are from the equator. For example, our school has a latitude 28.4 degrees, but if we were in South Africa, our latitude would be 34 degrees. Our latitude would be 34 degrees negative or to the south. Another example is New York City with a latitude of 40 degrees positive.
Let's now talk about the longitude. The longitude is used to calculate the sundial. It is represented by meridians or imaginary vertical lines that go from pole to pole on the Earth. The first, or prime meridian, indicates the time 0, and it goes through London. The distance between each meridian is 15 degrees, or 1 hour. For example, when in Orlando, it is 10 a.m., while in China, it is 10 p.m., because we can count 12 meridians from Orlando to China. The left of the prime meridian, or the east, or the west, is negative, while the right side of the prime meridian is positive, or east.
Any sundial has two main parts, the sphere and the gnomon. The sphere is the one that has the numbers and the timelines. The gnomon is the object that casts the shadow. Every sundial is different, and all gnomons are different lengths and heights. Our gnomon has a right angle, and our sphere lays horizontally on the ground. We built a horizontal sundial.
It is very important to replicate the sundial correctly. The gnomon will always have to point north, so it is parallel to the north-south axis of the Earth. Above the North Pole, there is the North Star, which is on the same plane of the north-south axis. To ensure that the hypotenuse is aiming at the North Star, we give the gnomon a 28.4 degree inclination, just like our local latitude.
Now that we know more about our school sundial, we need to know that the true time on the sundial is not the same as the official time on our clocks. The official time has several deviations due to many variables. To cite only a couple of them, for example, the saving time during some months of the year has an hour difference from the true time. The official time meridian taken by the government has a uniform time for big areas, not the local meridian. This is reasonable because it would be crazy to have one time at school and the other at home. Keep this in mind when you stand in front of a sundial to look for the shadow projected on the sphere, and it is different from the official time.